Most people write JavaScript like this. They create a variable, create a function, call the function, and move on. But have you ever stopped and asked, what is JavaScript actually doing before it runs this code? Look at this simple example. At first, this code looks very normal. We have a variable called name. We have a function called greet. And at the end, we call the function. Simple, right? But here's the interesting part. Before JavaScript even runs the first line, it already starts preparing things in the background. So in this video, let's slow everything down and watch how JavaScript actually executes this code. When JavaScript starts running a file, it creates something called the global execution context. Think of it like the main workspace where JavaScript manages the code that exists outside any function. This global execution context has two important parts. The first part is called the memory component, also known as the variable environment. This is where JavaScript stores variables and functions before the code starts running line by line. The second part is called the code component, also known as the thread of execution. This is where JavaScript runs the code, one line at a time. So before JavaScript executes our code, it first prepares memory. Then, after memory is ready, it starts running the code line by line. Now let's see what happens before JavaScript starts running the code line by line. This first step is called the memory creation phase. In this phase, JavaScript scans the code and prepares memory for variables and functions. It starts from the top and sees this line. JavaScript says, okay, I found a variable called name, so it creates space for name in memory. But it doesn't store John yet. Instead, it stores undefined. So in the memory component, we now have name as undefined. This is very important. The variable exists, but the actual value is not assigned yet. Now JavaScript continues scanning the code and sees this function called greet. Because this is a function declaration, JavaScript stores the whole function in memory. At this point, JavaScript still hasn't printed anything. It hasn't called the function. It hasn't assigned John to name. It has only prepared memory. Now JavaScript enters the second phase. This is called the execution phase. In this phase, JavaScript starts running the code line by line. Now it comes back to the first line. During the memory creation phase, name was already created with the value undefined. But now, during the execution phase, JavaScript assigns the real value. So name changes from undefined to John. Next, JavaScript reaches the function declaration. But this function was already stored in memory during the first phase, so JavaScript doesn't need to do much here. It simply moves to the next line. Then JavaScript reaches the line where the function is called. Now we are calling the function, and this is where something new happens. Whenever a function is called, JavaScript creates a brand new execution context for that function. So now JavaScript creates a new function execution context for greet. Now we are inside the greet function. Just like the global execution context, this function also gets its own execution context. That means it also has two parts, the memory component and the code component. First, JavaScript starts with the memory creation phase inside this function. It looks inside the function body. Inside this function, JavaScript finds a variable called message, so JavaScript creates space for message. But again, it doesn't calculate the final value yet. It stores undefined. So inside the greet execution context, memory looks like this, where the value of message is undefined. Now the function memory is ready, so JavaScript enters the execution phase inside the greet function. JavaScript runs the first line inside the function. JavaScript needs to create the value for message. The first part is simple, but then JavaScript sees name. Now JavaScript has a question. Where is name? It first looks inside the current function context. Inside greet, we have message, but we don't have name. So JavaScript looks outside the current function. It goes to the outer context. In this case, the outer context is the global execution context, and there JavaScript finds name. Now JavaScript can complete the expression, so message becomes hello John. Inside the greet execution context, memory changes from message having the value undefined to message having the value hello John. Now JavaScript moves to the next line, where we print the message variable using console.log. JavaScript looks for message. This time, message exists inside the current function context, so JavaScript finds it immediately and prints hello John. Now the function has finished running, and when a function finishes, its execution context is removed, so the greet execution context is deleted. The message variable also disappears because it only existed inside that function context. Now JavaScript goes back to the global execution context. At this point, there is no more code left to run, so the program is finished. So let's quickly recap what happened. When JavaScript started running the file, it created the global execution context. That context had two parts, the memory component, also called the variable environment, and the code component, also called the thread of execution. During the memory creation phase, JavaScript prepared the variables and functions. For our code, it created name with the value undefined, and it stored the complete greet function in memory. Then, JavaScript entered the execution phase and started running the code line by line. First, it assigned the value John to name. Then it reached greet with opening and closing parentheses. Because greet is a function call, JavaScript created a new function execution context. Inside that function context, JavaScript created the message variable with the value undefined. Then, during the execution phase, JavaScript created the final value for message using hello plus name. It looked for name, found it in the global execution context, and used its value, John. So message became hello John. Then JavaScript printed the message. Once the function finished running, its function execution context was removed. That's the main idea. An execution context is like a workspace that JavaScript creates to manage memory and run code. Now let's look at a small twist. What happens if we write this? First, we have console.log with the name variable inside the parentheses. After that, we declare a variable called name and assign the value John to it. What do you think the output will be? Some people expect an error because we're trying to use name before its declaration appears in the code. But with var, JavaScript prints undefined. Why? Because of the memory creation phase. Before JavaScript starts running the code line by line, it scans the code and creates memory for the name variable. During this phase, name is created with the value undefined. Then the execution phase starts, and JavaScript runs the first line, console.log, with name inside the parentheses. At this moment, name already exists in memory, but its value is still undefined. That's why JavaScript prints undefined. After that, JavaScript runs the next line, where we declare name and assign John to it. The memory value is now updated from undefined to John. So the key idea is simple. During the memory creation phase, JavaScript creates the variable and gives it undefined. During the execution phase, JavaScript reaches the assignment and stores the actual value. This behavior is commonly explained as hoisting, and it becomes much easier to understand once you understand execution context. Now let's try another example. This time, we call the function before its declaration appears in the code. On the first line, we call greet using the function name followed by open and close parentheses. Below that, we declare the greet function, and inside it, we use console.log to print hello John. What do you think will happen? Will JavaScript give us an error because the function call appears first? Actually, this code works, and JavaScript prints hello John. This happens because during the memory creation phase, JavaScript sees the function declaration and stores the complete greet function in memory. So even though the declaration appears below the function call on the screen, the function is already available before the execution phase begins. Then the execution phase starts. JavaScript reaches the first line, where we call greet. Because the function already exists in memory, JavaScript can run it. This is why a function declaration can be called before it appears in the code. Again, the behavior becomes clearer when we separate the process into the memory creation phase and the execution phase. Now you might be thinking, okay, this is interesting, but why does it matter? It matters because many confusing JavaScript concepts begin with this same idea. Hoisting makes more sense because we now know that JavaScript prepares declarations before running the code line by line. The scope chain makes more sense because JavaScript looks for a variable inside the current environment first, and if it can't find it there, it checks the outer environment. Closures also become easier to understand because a function can keep access to the environment where it was created. And the call stack makes more sense because JavaScript needs a way to manage the global execution context and every new function execution context created during the program. This understanding will also help when we later discuss the event loop, because the event loop works together with the call stack to decide when queued code can be executed. So whenever you look at JavaScript code, don't just ask, what will the output be? Ask two better questions. What happens during the memory creation phase? And what happens during the execution phase? Once you start separating those two phases in your mind, JavaScript becomes much easier to follow. That's execution context. It's the workspace JavaScript uses to prepare memory, execute code, and manage function calls behind the scenes. In the next video, we'll take this one step further and understand the call stack. Because if an execution context is a workspace, the call stack is the system JavaScript uses to organize and manage all those workspaces.